Hello students, this session we will see merge sort. Last session we have seen bubble sort, selection sort, insertion sort, right? The next very simple algorithm, merge sort. It is unlike other sorting algorithms where here we are using divide and conquer technique. That is, we are dividing the given array, right, into two subparts, two sub-array. Then I separately merging that subarray, separately sorting that subarray. So then later those sorted array can be merged together, right? So here we are using divide and conquer technique, right? First we have to divide a whole given array into two subarrays. Then the subarray can be sorted. Then both can be merged together to get the whole elements in an ascending or descending order, right? So this is the working mechanism of merge sort. So how we can make this dividing and merging? So definitely we have to do in recursive manner. Recursively we have to divide that array, right? And then recursively we have to merge the array after sorting. See, it's done recursively, and then you have to keep dividing that array from the first element till mid, and then from the middle element to end. That is two subarray, two subhalves. Then we have to sort that subarrays. Then we have to join them or merge them back. So no issues. We'll see with one example. Very simple logic. So here we'll consider 6 elements for sorting using merge sort algorithm. So here we are considering ascending order, right? See, we took 6 elements where these are the array elements and these are the array index. So we are considering beginning index and end index, right? Starting index of the array and last index of the array. So we have to find the mid position, right? We have to find the mid position to split the array. How we can find the mid position? So before that I'm just checking whether beginning less than end. So what is the value of beginning index? 0. Index, not value. For dividing we are just considering index. So I'm just considering an index. Here the index, beginning index is 0. What is the last index of that array? 5. So whether 0 less than 5? Yes. So if that is true, then we can divide the array into two halves. First step is we have to divide that array into two halves, right? So how we can divide? So the split we have to find, where from till we have to split it, right? So how we can find? So we have to find the mid position. Formula is beginning index plus end index divided by 2. What is the beginning index? 0, not value. To find the middle position we have to consider only index, not the value. So beginning index is 0, end index is 5. So 0 plus 5 by 2. So you may ask, it's 2.5 ma'am, why 2? So only we are taking interest of only integer part. Ignore the after floating point numbers. Just we are considering only integer part. So mid is equal to 2. That is position, right? That is, what is the position? Second position. So till second position. Till second position, we can consider this as a first of. And after mid position. After that second position till the end, I can consider as a and another half. We will see. So we found mid as 2. So that is 2 is the division position. So just I consider only the left array. See, this is a mid position. So this will become left half. These three will become right half. Okay. So these are the left side elements. That is left array elements, sub array elements. 5, 4, 3. What are the index? 0, 1, 2. Now again, recursively, I will split this. First, we will finish left side, then we will concentrate on right side. So initially, we split it into 2 sub-hops. Again, this is my whole array now. Now again, I have to split it. So till I get a single element, I have to recursively do the same, right? So here, what is the beginning index? 0. What is the last index? 2. I'm checking whether beginning less than last index. Yes, of course, 0 less than 2. So what is the next step? I have to find the middle position. What is the formula to find the middle position? Beginning plus end by 2. What is beginning? 0 plus 2 by 2. So what is the value? 1. So 1 is the middle point. So till 1 I can have this as a left subarray. This one value can be another subarray. We'll see with the animation. So beginning less than end, yes, 0 less than 2. So using this formula, we are just dividing into 2 arrays. So mid position is 2, mid position is 1. So what will happen? This till this will split into 2 arrays. So 5, 4 will be again will become left subarray, and 2 and 3 alone will come in right subarray. That we'll see again, because we have one more array, right? We are checking whether less than beginning less than end or not. 0 less than 1. Yes, of course. Again, what we have to do? We have to divide. I'm just dividing into 2 halves. How to? Beginning index plus last index divided by 2. So 1 by 2, 0.5. So we are considering only integer part. So 0. So till 0, 1 half, and 1 will come into the another half. So how the split can be? 0 index is in left subarray, and the value 1 can come in right subarray, right? Yes. Now left subarray and right subarray. Now in both left subarray and right subarray, we have only one element. So no need to split again. Now we can start the merging. Now division is done. That is only in left subarray we are concentrating. We have done with the dividing part. Now we have to concentrate on merging part. Since we reached the one element splitting, so we can start with the merging. So before merging, we have to sort it, then we can merge. See, look into this. 5 and 4, 4 less than 5. So we are just swapping 4 and 5. 4, 5 swapped. Now it is perfectly fine. That subarray is sorted. Now we will concentrate on right subarray. 2 and 3 is there, right? Since that is the one element, we didn't do the subdivisions. Now 3 is cross-checked with each and every element. So where it should be moved? To the 0th index position, right? So this is checked with 1 by 1. Then it is moved to the proper place. Now it is again sorted. Now left subarray is properly sorted. In the same way, we can move to right subarray. Right subarray is what? Values are 1 to 6. Indexes, that is for splitting, we can consider as 0, 1, 2, or you can consider 3, 4, 5. Programmatically, you can fix it, no issues, right? You can keep it as 3, 4, 5 also, no issues. Then same way, accordingly you have to do this minor changes in your code. Or 0, 1, 2 also you can give. That is, everything can be done in programs, right? But concept is same. You have to split it, you have to divide it, and then you have to merge that. So beginning less than end, yes, same procedure. We have to find the mid position. So 0 plus 2 by 2, of course 1. So till 1, 1 left sub half, and right side it is another sub half, right? So again left sub half having more elements, checking with beginning less than end, yes, finding mid position, considering only integer part. Then these two will be separated, left subarray and right subarray. Because left side only one element, now we can concentrate on right subarray. Again, right subarray is also only one element. So now both elements can be sorted. So there is no need of swap because already it is in proper order. Now left subarray is properly sorted, right subarray is 6, right? So we are just checking with each and every element, no need to sort because it is already in proper position, 1 to 6. So since right subarray also only one element, then only we can go with sorting that elements. Now after sorting with subarray, we are checking with all the elements in left subarray. Since all the order is properly fine, we are not doing any swapping, just maintaining as such. Now left subarray and right subarray is fine. Now both left subarray and right subarray is properly sorted. Now we have to merge those two subarrays again in ascending order, right? Left subarray is properly sorted, right subarray is also properly sorted. Now each and every element we have to take and then we have to fix in a proper position. So starting with, so the value 1 should go in that position. Then yes, then coming to the left subarray, yes, finally 6 will be replaced there, right? So we got the sorted array. So like this, we have to do the division first and then merging. So this technique we can call divide and conquer. We are dividing in, we are splitting, and then we are merging, right? So we'll see with the code then. See, merge are coding. Coding part you have to understand what we are doing. We are just splitting continuously, recursively we are splitting, right? And later we are merging, and the merging part we should have another new array to put that values. Each and every time we have to compare that already sorted array, then we have to put it in proper place, right? So as usual, first thing, function declaration. What are the input we have to pass? Yes, array. We should know what is the beginning index and end index, right? Here we are using two methods. One is we are just dividing, right? And after dividing, we are just combining that sorted array. Okay. So first, this is the part to divide. Okay. The second method is used to merge those divided array. Okay. So in main function, we can just doing the necessary declarations. This is the function called we are making. What is the function called? What are the arguments we are passing? Array reference. Starting index is nothing but as usual 0. And end index. Since size is 3, 4, 5, 6 values and sending means end index. So obviously one it should less by 1, right? So size minus 1. That is beginning 0 and end is 5. This is for to printing the starter elements. So before that, the function should go to the function definition. This function call will be reverted to this function definition. What we are doing? Nothing but recursively we are splitting. Before that, what is the condition? We have to check the beginning index value less than end index value. If it is that, what we have to do? We have to find the mid position. Later, what we have to do? Three things we have to do. You have to split left array completely. You have to divide the right array completely. Then you have to merge those array in a sorted order, right? So what will happen? This merge sort, first merge sort, what it will do? That is, here we are sending beginning and end. That is array reference, beginning index and mid index. That is first half. Only first left half. So recursively it will do. This first method will be called recursively. So till this become false, this beginning less than end become false, it will do recursively till it split into unique element, right? Then if it gone fail, then the second method will be called, because it is recursive, right? So in recursion, what will happen? Each and every time it is calling the function, it go to function definition. Once it is done, again it should come back to the function call. So it will automatically, it will start with the next statement. That is the purpose of recursion we are using, right? It will come to the method where it is called, and then it will, as usual, it will start with executing the next statement. What is the next statement? Again, we are calling merge sort. That is, this is division for second half array from the mid plus 1 till the end. Here I'm just splitting the array, right? I'm just splitting it. This is second half. So in the first call, I have splitted the first array, first half array, that is from the 0th position till the mid position. In the second method call, what I'm doing, from the mid position till the end, I'm just splitting it. Now my whole array is completely splitted into unique element. Only one element in one array, right? Later, what is the purpose of this method? Here I am sending complete details. Array reference, beginning, mid. That is these for first half array. Then from the mid plus 1 till the end, this is details for second half array. Here what I'm doing, each and every element will be cross-checked with another element, and it will be merged together with the proper ascending order, right? So this is very simple algorithm. First you have to split it and you have to merge it. That's all. For splitting and merging, you can use, for splitting you have to call recursively the same array, because you should use recursion function till the array of elements gets splitted into unit element, right? Later you can sort those elements, then you can merge. Okay guys, this is all about merge sort algorithm. Next session we will see with another sorting algorithm. Thank you everyone.